Hello everyone, my dear students of class 10th. In my previous lecture, I told you about the concept of charge, electricity, potential difference, electric potential, Ohm's law, as well as the basic definition of resistance. Today I am here to just tell you about the four topics of same chapter: factors affecting resistance, resistivity, classification of materials on the basis of resistivity, and combination of resistance. So in that scene, I'm going to start the first topic: factor of affected resistance. Resistance is what? It is hindrance, it is obstruction offered by that wire in the direction of motion of current. Now, if we talk about on which factor the resistance depends, so there are two important factors. The first one is length of that conductor, and second one is area of cross section of that particular conductor or wire. Over the length, it varies directly. Means if the length of resistance will increase, if the length of wire will increase, resistor will increase, then the resistance will also increase. And for the area, it depends upon inversely. Means if the area increases, resistance decreases, or area decreases, resistance increases. On combining these two mathematical factors, you will get R proportional L by A. If you remove this proportionality sign from here, you will put an equal sign, and with the help of that equal sign, you will also introduce a constant. The constant term here is known as resistivity, rho. This is called rho. Remember the spelling RHO, rho. This is symbol rho. One more factor on which this particular resistance depends, that factor is called temperature. Means resistance also depends upon temperature. How it depends? I will discuss in next topic. Here you know only this is a formula, very important formula. You will the derivation of this formula you will study in the higher classes, that alpha is equals to R2 minus R1 upon R1 into T2 minus T1, where this T2 and T1 are the temperatures, two different temperatures. This formula indicates that when the temperature of the wire was T1, resistance was R1. If the temperature becomes T2, resistance becomes R2. Then there is a formula which relates this dependence of temperature over the resistance, and the constant which is introduced here, that constant is known as temperature coefficient of resistance. In the same way, because resistance varies directly with the resistivity, in the same way we can convert this formula for the resistivity also. You can see here. So these are the three parameters over which resistance depends. The question is, a term is here resistivity. Question is, what is resistivity? There is a two name of resistivity. The first name is specific resistance, second one is resistivity. Both are same. When we define the resistivity in this particular formula, look here. If we suppose L is 1 meter and area of cross section is 1 meter square, means there is a conductor, there is a wire whose length is 1 meter and area of cross section is 1 meter square. So when we put 1 here, you will get R equals to what? Resistivity. Means resistivity is the amount of resistance. Look here, resistivity is the amount of resistance of a conductor whose length is 1 meter and area of cross section is 1 meter square. If you talk about the unit of resistivity, then from this relation you can say resistivity is R into A by L. R is ohm, this is meter square, this is meter, cancel, what you will get? Ohm meter. So this is the unit of resistivity or specific resistance. The next, third topic is classification of materials on the basis of resistivity. There are four types of materials: conductors, semiconductors, insulator and superconductor. Conductor, if we take the example like metal, for that resistivity varies directly with the temperature. Means those substances are said to be conductor whose resistivity increases on increasing temperature. Suppose that silver is there. Silver is a conductor. Now, if you increase the temperature of this particular silver metal, then what happens? Its resistivity will also increase. Resistivity increase, that is why its resistance will also increase, because resistivity and resistance both are directly proportional to each other. So such type of materials are called conductors. Semiconductors are those, you can say, materials in which electric current flow partially, not smoothly, partially. There are two examples, germanium and silicon. For here, resistivity varies inversely to the temperature. Means what? If temperature increases, resistivity decreases. Same for resistance also. And the third one is insulator. Insulator means what? In which current cannot flow. For insulator also, resistivity proportional inversely proportional to the temperature. Same thing. Practically what happens, there is no free electrons in the insulator due to the resistivity is very high. The resistance is very high. So if anyhow we want to decrease the resistivity, we have to increase the temperature. Now the fourth one is superconductor. Superconductors are what? Such type of metals whose resistivity becomes zero below a certain temperature. That temperature is called critical temperature. Means below that temperature of those metals whose resistivity becomes zero. Means if we decrease temperature, we will get a certain temperature over the resistivity becomes zero. At that moment, that particular material is called superconductor. So this is factors, resistivity and classification of materials. Now, suppose that you can see in your house also there are three wires. This is wire first. This is the symbol of resistance wire. Remember this. R1. This is another wire. R2. This is another wire. R3. Now these three wires are there. Now the question is how you will combine these three wires. So there are three methods to combine these three wires. In which the first method is called series combination, second method is called parallel combination, and third method is called mixed combination. Now I will tell you one by one what happened in series combination, what happened in parallel combination, and what happened in mixed combination, and what is series combination, what is parallel combination, and what is mixed combination. Okay. Now look what happened in series combination. This is first resistance wire, resistance is R1. This is second, resistance is R2. This is third, resistance is R3. Now if you join these wires end to end with each other, end to end is what? First wire, then connected wire, second wire, connected wire, third wire. Resistance is R1, R2, R3. Then this combination is series combination. Now apply an external source like any cell. This is the symbol of cell. The symbol plus shows current will go from this side, minus shows current will come out towards minus side. Now the current is going in this way. There is only one direction of motion of current. And what you are getting whatever the amount of current is going from here, reaching here, reaching here, reaching here. Means whatsoever be the value of resistance of the wire, amount of current in each resistance wire is same. So this is the key point of series combination. If number of resistors are joined end to end and amount of current is same for all the resistors, then the combination is called series combination. Now here, across these two ends, potential is this. Across these two ends, potential is this. Across these two ends, potential is this. Question is why potential difference is different for all the three wires? The answer is what? Because potential is what? Work done to bring the charge from one point to another point. Now you can see from here to here the distance is different, but for here to here distance is different, but for here to here distance is different. So because distance is going to change continuously for here, that's why work done will be different, and if work done will be different, then potential will be different. That's why potential here is V1, here is V2, here is V3. Therefore this is net potential offered by the cell. So this net potential V is what? Sum of all the potentials. Whatever the potential distributed here, when you add all the potentials, you will get net potential. From Ohm's law, V equals to IR. For here Ohm's law, IR1. For here Ohm's law, IR2. For here IR3. I you take common, then you will get a formula R equals to R1 plus R2 plus R3. So with the help of this formula, you can calculate the net resistance of a particular circuit in which number of wires are connected end to end like this I have shown here. Second one is parallel combination. In parallel combination, if the wires are connected in this is first wire, this is second wire, and this is third wire, R1, R2, R3. You can see in the figure all the wires are connected across each other. Now connected from any external source, net potential is here is V, current is going from here, coming out from here. Now this current is going here, and you can see the current will distribute into three parts. I am not saying equal part, it depends upon what is the amount of resistance. Let the current here is I1, here is I2, here is I3, then same I1, I2 will come from here, collect here, it will become I, then comes outside on the minus terminal of the external source. Now, regarding potential, potential will be same. In parallel combination, potential will be same across all the three resistors. Question is why? Because you can see the charge travel from here to here, for this resistor here to here, for this resistor here to here. Means what distance is same, so what will be same. That's why potential will be same. Now apply, when you will see here current distributed means I is in three part. From Ohm's law, V by R, here V by R1, here V by R2, here V by R3. Take V common, you will get a formula to calculate net resistance when the number of resistors are connected in parallel combination. So this is the formula of parallel combination to calculate net resistance. This is the formula of series combination to calculate the net resistance. So this is about series and parallel. The third one is mixed combination. Mixed means such type of circuit in which some resistors are connected in series as well as some are in parallel. For example, for these two resistors, this is R1, this is R2, this is R3. Now you can see these two are in parallel, then series also means series parallel both are present in one circuit, then the combination is known as mixed combination. There is no particular formula to solve the net resistance for mixed combination. It depends upon some parameters. That circuit is of what type. It is simple circuit or it is complex circuit. In your class 10 standard only simple circuits are there. There is no need to make the complex circuit in class 10. But when you will go in higher classes like in class 12, you will study so many processes to find the different parameters of that particular circuit in the mixed combination. For the mixed combination, we always think one thing, that the direction of current. Here you can see these in this two particular section, current here and current here is distributed, means parallel. And whatever the current is going from here, same current is coming here, but after reaching here distributed into two parts, means these two coming in parallel combination. And when you solve these two, so because same current distributed two parts, so when you combine, again same current will come. So this and this whole section result will be in series combination. In this way we can solve the numericals based on mixed combination. I will tell you some numerical based on series, based on parallel, based on mixed combination in my next video lecture. Till then you watch this video, like it, subscribe my channel and get the advantage. Okay, all the best. God bless you.